Namaskar, this is Late Edition. On the show tonight, we'll discuss about Srinivasa Ramanujan's intuitive mathematics, the last of which has, taken 90 years to solve and has also opened the door to the understanding of black holes. Now, Indian maths genius Srinivasa Ramanujan's cryptic deathbed theory, which he claimed was conceived in his dreams, has finally been proven correct, almost 100 years after he died. Interestingly, the news about it came at the end of 2012, which was also the National Year of Mathematics in India, and in honor of Ramanujan's 125th birth anniversary.
Srinivasa Ramanujan was born at Erode, Tamil Nadu. Ramanujan's introduction to formal mathematics began at age 10 with almost no formal training in pure mathematics. Ramanujan developed his own mathematical research in isolation. As a result, he sometimes rediscovered known theorems in addition to producing new work. Ramanujan found his mentor in G.H. Hardy, the renowned English mathematician. Ramanujan made extraordinary contributions to mathematical analysis, number theory, infinite series, continued fractions, and the Ramanujan conjecture. Lately, Ramanujan's cryptic deathbed theory, which he claimed was conceived in his dreams, has finally been proven correct almost 100 years after he died. In 1920, while on his deathbed, Ramanujan wrote a letter to his mentor, English mathematician G.H. Hardy, outlining several new mathematical functions never before heard of, along with a hunch about how they worked. Researchers say they've proved he was right and that the formula could explain the behavior of black holes.
It's a matter of concern that for a country of our size, the number of competent mathematicians that we have is badly inadequate.
It is significant that in the end of National Year Mathematics 2012, Ramanujan's theory on cryptic functions, which was in oblivion for 90 years, came into the limelight. Ramanujan was a genius paralleled by none. It is high time that India produce more mathematicians of caliber. Vinod Kumar DV's report, DD News.
Well, and to discuss Ramanujan's theories, we are joined by an eminent panel. We are joined by Professor Parveen Sinclair, Director of NCERT. We are also joined by Dr. Santa Lesram, who is Assistant Professor of Mathematics at the Indian Statistical Institute, Delhi. And we are also joined by Professor A.K. Agarwal, who is Professor, Department of Mathematics, Punjab University. Thank you very much, sir, joining us from Chandigarh. And we are also joined by our correspondent for Science and Technology, Vinod Kumar DV. Well, we'd start with you, Professor Agarwal. What, in layman's terms, would we describe as the cryptic field equations?
In his last letter to G.H. Hardy, which he wrote 3 months before his death, he wrote a letter and he sent a list of 17 functions in that letter, and he said that recently I have discovered these functions which fit into mathematics as beautifully as Jacobi's theta functions, and I call them mock theta functions.
Okay.
Now recently, using these mock theta functions, two mathematicians in American University, Wisconsin University, solved an old number theory problem. Freeman Dyson,
right,
in 1944 posed a number theory problem that whether it is possible to find the elegant formulas for the number of partitions with even rank and with odd rank. And these two mathematicians solved this problem recently by using Ramanujan's mock theta functions. Professor
Right.
George Andrews of the Pennsylvania State University, he did his PhD on Ramanujan's mock theta function.
Right.
And in 1976, he went to Trinity College, London, and he discovered lost notebooks.
Okay.
And since then, he has been writing papers after papers on Ramanujan's notebooks.
You have given us quite an introduction there as far as the work that Ramanujan has done. But tell us a little bit about his mind, because from a layman's point of view, we understand he's a genius, and the fact is that he thought out lots of equations and theorems and things like that, which he couldn't quite explain. that doesn't seem to make much sense, you know, to an ordinary man, because how can he think the entire thing through but not explain it?
See, in mathematics research, there are two important aspects. One is the intuitive imagination, and the second is supplying proof. And Ramanujan was having the imagination as the great mathematicians like Gauss, Jacobi and Euler were having. But because he was not having any formal training,
right,
so he was not able to supply the proof. Ramanujan was able to capture the British intellectual fortress called the Royal Society, and he became the member of the Royal Society even before Nehru and Gandhi could impress upon the British Empire that Indians have brains.
Professor Sinclair, the reason perhaps that we don't produce enough in terms of you know, what the Prime Minister said, adequate high caliber mathematicians, is perhaps because we are not focusing on the intuitive aspect of mathematics, is it? Would one say that? Because a lot of mathematics, you have to have it, some would say, in your blood. You have to be a mathematician.
Well, I am a mathematician, and I wouldn't say it's in my blood as hereditary, but a culture of thinking on your own, with an open mind, looking at things critically, generalizing. These are the mental abilities that mathematics allows you to do, if you're exposed to it in the way that we would like children to be exposed to. We meaning from the NCERT curricular framework at present, NCF 2005. What happens is, be it science or be it mathematics, the way it is done in schools is focusing on the algorithmic part, procedural part. Take this as given, and now you know, do several problems in the same vein. Science, you're given a result and you say, now you do experiments and come to the same result, rather than, you know, with an open-ended way of looking at it, which is what science is about. So the mathematical reasoning processes are not processed in the minds. Intuition is not intuition per se. For example, when I do algebra over the years, it is an educated intuition. You've seen and understood and noticed, observed, absorbed, and you make somewhat educated guesses. In the case of Ramanujan, what is different was that these guesses came from nowhere. They were truly, in some sense, intuitive, and neither did he understand where they came from, nor did Hardy or the others understand. And when they tried to put it into some kind of structured framework, slowly they started unraveling something, and still he would, you know, keep working in this manner that was confounding him and his peers. So it's a very different kind of intuition that he was working with. It's not just the deathbed theorem or the Mach theta functions, which actually from 1914 on, they were coming to him as recorded. But about 4,000 results, which people didn't really understand, small and big, including, you know, things like relating pi to a convergent series of a certain kind and so on, were done by him.
Right, we'll take a short commercial break. There's a lot more to discuss. Do stay with us.
ये है हमारे दोस्त सरदार बलविंदर सिंह। ये रहने वाले पंजाब के हैं, लेकिन काम यहाँ झारखंड में करते हैं। क्या इनका यहाँ पर आधार नंबर का पंजीकरण हो सकता है?
बिल्कुल हो सकता है। आधार संख्या का पंजीकरण देश में कहीं भी हो सकता है।
क्या पंजाब में मुझे दूसरा नंबर लेना पड़ेगा?
आधार संख्या सिर्फ एक बार लेना होता है, वो चाहे आप यहाँ लें, चाहे पंजाब में।
ये रहा आपका आधार पंजीकरण।
आधार का पंजीकरण कराएं देश भर में कहीं भी। आधार, आम आदमी का अधिकार।
अरे गेट खोलो। अरे भाई टॉर्च क्यों मार रहे हो? दिखता नहीं कौन है?
माफ करना साहब, आपकी हाई बीम ने मुझे अंधा कर दिया, इसलिए चेक करना पड़ रहा है। मैंने देखा है कि लोग हाईवे पर हाई बीम का इस्तेमाल करते हैं, लेकिन साहब आप तो कॉलोनी में ही।
सॉरी। हाँ,
लो बीम पे चलें, सेफ चलें।
हेलो अंकल।
हेलो।
बड़ा खुश है। फर्स्ट आया है क्या?
फर्स्ट तो हमेशा ही आता है, पर अब ऑटोमोबाइल इंजीनियरिंग के लिए स्कॉलरशिप जो मिले हैं।
देखे हैं जो सपने, सच कर दिखाए।
मेरिट कम मीन स्कॉलरशिप से अल्पसंख्यकों को मिल रहे हैं आगे बढ़ने के अवसर। आइए इसका लाभ उठाएं। राज्य सरकारों द्वारा समाचार पत्रों में दिए जाने वाले संबंधित विज्ञापनों पर आप नजर रखें। आप बढ़ेंगे, देश बढ़ेगा।
Welcome back. Well, Dr. Laishram, would you feel that, you know, you're involved in this field of research and mathematics? Do you feel that the numbers of people coming into the field are declining? And could you perhaps give us some reasons if that is true?
Now people are more inclined to get jobs right after education without, and if you are like doing research or going for PhD, then becoming a professor, it takes a long time, then lot more work needs to be done, whereas you just complete a bachelor's degree, get an MBA and start earning what a professor or will earn. And secondly, like sort of the importance of basic mathematics, basic sciences, particularly mathematics, is not that well understood by the common people in general, because people think that okay, now mathematics, so 1 + 2, 1 + 1 = 2, that's all. Many times I was asked when I told people that I'm doing mathematics, so they asked me 1 + 1 is 2, what else you can do? So sort of people have a different kind of concept towards, and many people either they like mathematics or they hate mathematics.
So you should have introduced them to Ramanujan, and then then you would have understood that there is a lot more that one can do with mathematics. Well, we'll bring Vinod into the discussion now. Vinod, you've keenly been studying black holes, and apparently this kind of theory is going to help in the understanding of black holes. But tell us a little bit about black holes itself and how they come about.
Sure, Mark. Black holes are can be called as scientific miracles. To be exactly, black hole was discovered in the late 1960s using our physical apparatus. But initially, in the 1915s, Albert Einstein came up with a theory called general theory of relativity. And solving the field equations of the general theory of relativity, Carl Schwarzschild came upon a point called singularity and event horizon. At that time, many people didn't understand. It happened simultaneously for Ramanujan, whereby he gave this mock theta functions and mass equations, whereby at that point of time no one was able to understand. Black holes are stellar remains. When a star is having a radius of crores and crores of kilometers, and it is set by balancing equations of force of gravity which sucks in and the nuclear energy which explodes out. When we have the balance of both of these forces intact, a star is said to be stable.
Right.
But in the due course of time, when the star depletes of its hydrogen and the carbon-nitrogen cycle will come to an end, then the star is not stable. The gravity will try to suck in everything. So at last a supernova explosion happens, and if the mass of the star is more than 1.4 times the stellar mass, that's our solar mass, then it will convert into either into a neutron star or a black hole. And a black hole is like its term, black hole is completely black, nothing comes out of it. From the event horizon, that is the external part of the black hole, nothing can escape, even light cannot escape. And we discovered black holes by its properties known as gravitational lensing effect, whereby if a black hole passes through a galaxy or a star, it will bend the light, and this bended light will be received by the radio telescopes and our Lumina telescopes in Earth.
So what you're trying to also, from layman's point of view, tell us, Vinod, a black hole can suck up the entire, planets, etc., everything into it?
Yes, Mark. A black hole is able to suck up anything in this universe. A black hole is having a radius of only 30 kilometers, and it can suck up virtually galaxies. Even galaxies which are light years apart can be sucked in a single black hole. For example, our Milky Way black hole, we are in the center of the Milky Way black hole. In the center of Milky Way, it is, imagine that a supermassive black hole is there, and the entire Milky Way is revolving around the supermassive black hole. Recently, we had renewed interest in the black holes at Large Hadron Collider, where it was widely speculated that primordial black holes or mini black holes may be generated and which can suck up Earth. Unfortunately, it doesn't happen, and Einstein's Maxwell's field equation stands strong. And the mathematical thing is that in 1916, Einstein and Carl Schwarzschild predicted the existence of a thing called black hole using mathematical ways. The same way, we have got another ingenious tool from our own scientists that can help us explore more of black holes, and it can give us insights to how the galaxy and how it will work in the future.
Professor Sinclair, would you like to tell us a little bit about Ramanujan's contributions in terms of the understanding of pi for one?
Well, yes, as far as pi goes, there is this very interesting result, very brief, and again don't know how he has arrived at it, is amazing numbers in this formula with convergent series. Who would think of 1103 plus 26,390 n by 396 raised to the power 4 n. Now, how he has arrived at this, we still don't know.
Okay.
But as far as black holes and all these, you see, we work in, many of us work in mathematics because of the love of it. He had a passion for numbers, and he'd see the most amazing connections in numbers. There is what is called the Ramanujan number, 1729,
yes.
Okay.
1729.
Now, it's the smallest number which is written in two ways as a sum of the cubes of integers.
It's called the Hardy-Ramanujan number, actually, right?
So, Hardy, because Hardy is sitting with him and worked this out when Ramanujan
Actually, there was an interesting story about that. In fact, I'll ask Professor Leshram about this. You know, the fascinating story is that Ramanujan was unwell, and then Mr. Hardy went to see him, and he went in a taxi which was number 1729, and he said this is a very dull number, and immediately Ramanujan said it's not a dull number, and he explained to him that in fact it is
sum of
absolutely. What did he explain?
Actually, so that's the smallest number which can be written as sum of two cubes in two different ways. That way is kind of interesting because this is the smallest, and people started looking up how many such numbers are there, and one can see that the next number which can be written and that way is again too big.
But you see, the whole thing is just pure arithmetic, pure numbers, number theory. It's not per se for an application outside mathematics.
Right, and he came upon, he just thought this out even though he was unwell at that point of time. So it showed that his mind was very active.
And you see, what is very interesting about Ramanujan is, he in fact failed what was called the FA in those days. He failed it because he is interested in mathematics and not in the other subjects, English or whatever he was expected to pass in.
Right.
So this gentleman who was working in the Port Trust as a clerk, and he's interested, he's writing his notebooks, his ideas in all these notebook upon notebook, and he's running from department to, faculty to faculty, look at this is interesting, and then somebody, Madras University to its credit, did give him a scholarship. They helped him write to Hardy, then Hardy finally decided to, first he kind of put it away, but then something caught his attention. He looked into it. So this person who technically is not, has not passed all the various degrees.
Right.
Then he went to England and got his BA there through research.
Well, we need to take another short commercial break. Do stay with us.
हमने सोच लिया मैं पायलट बनकर उड़ जाऊंगा, मैं बनूंगी डॉक्टर, मैं बनूंगा इंजीनियर।
वाह, स्कॉलरशिप मिलने से सबके सपने बड़े हो गए।
प्री मैट्रिक स्कॉलरशिप से अल्पसंख्यकों को मिल रहे हैं आगे बढ़ने के अवसर। आइए इसका लाभ उठाएं। राज्य सरकारों द्वारा समाचार पत्रों में दिए जाने वाले संबंधित विज्ञापनों पर आप नजर रखें। आप बढ़ेंगे, देश बढ़ेगा।
टैंक फुल कर दीजिए। रुकिए।
क्या हो गया भाई साहब?
ये क्या है? पेट्रोल पे टैक्स?
सॉरी भाई साहब, ये लो भाई साहब, ठीक हो गया।
हाँ।
1000 का पूरा कर दूं क्या?
वो कैसे?
ऐसे।
अरे ये क्या कर रहे हो? अरे लिक्विड तो खुद ही बर्तन की शक्ल ले लेता है, ये हिलाने से कोई ज्यादा आएगा क्या? यार मुझे तुम पर भरोसा नहीं है। वो डब्बा कहाँ है? बुलाओ 5 लीटर का डब्बा अपना, भरो उसमें पेट्रोल। मैं देखता हूँ तुम्हारा मीटर सही है या नहीं।
खरीदारी करते वक्त पूरी जानकारी ले लें। याद रहे, आपकी सतर्कता ही आपका बचाव है। जागो ग्राहक जागो।
देखो गफूर, कितना खूबसूरत रत्न तराशा है मैंने आज। जिसके हाथ लगेगा उसकी किस्मत चमका देगा।
दूसरों की किस्मत चमकाने का काम, और इन कामगारों के हिस्से में अकाल मौत। कारण सिलिकोसिस, जो पत्थर या धातु की कटाई या घिसाई और ड्रिलिंग वर्क से उत्पन्न धूल में मिले वो महीन सिलिका कण होते हैं, जो काम के दौरान फेफड़ों में जाने से कामगारों की मौत का कारण बनते हैं। सिलिकोसिस से बचें, काम के दौरान धूल रोधी मास्क पहने, हाई प्रेशर वेट ड्रिलिंग और वेट कटिंग मशीन का ही प्रयोग करें।
Welcome back. Well, we're running short of time, so let's get concluding comments then. Professor Sinclair, from the point of view of school education and building up a culture for mathematics, how much can we learn from, Ramanujan? Because people would feel that, he's a genius and people are afraid of mathematics. Can things be made a little more, simple for them?
Several efforts are on in this country and in the world to get rid of this fear. The second thing is, not everybody will be a Ramanujan. In fact, probably nobody except for maybe another. But that is not what we want. We want people to build, as you were saying, a culture of thinking mathematically, which would move later towards getting more and more interested in mathematics and being retained in mathematics per se, instead of due to various, lifestyle and reasons of income, moving to other setup. Research is now being paid for more also. Salaries are rising in research institutes. We have a few good research institutes in the country, and we need to have people, good people with good backgrounds coming there.
Okay. Dr. Lasram, but some people think that what can one do with the mathematics research? Obviously, I mean, that would be a rather ridiculous comment, because, I mean, mathematics is like a language which can be used elsewhere. But the point is that some people don't find that going into mathematics, you can't get a job which is decent, as you were saying that, that you can only get into the academic line. But can you see in the future perhaps mathematicians moving into other areas?
In fact, right now actually it's not correct that you can only do academics. I mean, by being in mathematics, actually you can be in finance industries, you can be in internet security. For instance, this current internet security relies completely on prime numbers, which earlier considered to be sort of very basic thing. I mean, which is very important, like 2, 3, 5 numbers which are divisible by 1 and itself, these are primes, and people never thought that this will be so useful now that, I mean, whole backbone of internet security, mobile, all this internet banking transaction, everything relies on this security of
including barcoding.
So they work on prime numbers. So right now actually by being in mathematics, by mathematical thinking, you are more open to work at different areas, and I think not only you can stay in academics, but you can go to different industries or different work.
Right. Things, so. Professor Agarwal, how does one improve the interest in mathematics?
See, I tell you one thing, that from Ramanujan's story, we learn that mathematics is a very important, interesting and paying subject. So Ramanujan contributed in several areas.
Absolutely.
Like Mach theta function, partition theory, continued fractions, hypergeometric series. So he worked in different areas. And as Selvar commented, that we are grateful to Ramanujan, not only because he contributed so much, but he left so much for others to work on. And one more thing I would like to tell about Ramanujan is that he was a great human being. Not only that he was a great mathematician, he always gave the credit of his discoveries to the goddess Namgri of Namkhal. Right. And he said that the goddess comes in my dream and she gives me the formulas, and I just write down the formulas. He also said that no equation has a meaning for me unless it expresses the thought of God. So this is a very great lesson for the young people, that he was free from ego, a very humble man, and is a great inspiration for the youth of the country, because all over the world he is recognized as a great mathematician. Right. Even though he died at the age of 32 years, but we compare him with the great mathematicians like Gauss, Jacobi and Euler.
Absolutely. Finally, Vinod, you're a young man, and just tell us a little bit about how you were inspired, in terms of I also know that you're a very devout person, pretty much like Ramanujan in a sense, but I won't say that you're a genius. But tell us a little bit, about how you relate to this man.
His health deteriorated because of his devoutness. For example, I'll tell, he was a strict vegetarian. In England, it was very difficult for a person like Ramanujan to attach to the food of that country. So, being a great human being, he loved not to make athermic choices in his life. That's why he stayed a strict vegetarian, and that cost his life also, because at the mean end of his life, he developed tuberculosis, and as a result of malnutrition also. And one more thing, he had that Guru Shishya, that Bentha, that relation with G.H. Hardy. He took his all humble works he gave it humbly to G.H. Hardy as well as the goddess.
Okay.
And during his course of only 32 years he lived, and in his due course he developed some 3,000 to 4,000 solutions in different equations, and that's not a mean thing, and only it's an unparalleled genius.
Okay, we'll have to leave it there. Thank you very much, gentlemen, for joining us, and thank you very much, ma'am, for being with us. While on his deathbed, Ramanujan wrote a letter to his mentor, the English mathematician G.H. Hardy, in 1920, and he outlined several new mathematical functions never before heard of, along with a hunch about how they worked. And American researchers now say that Ramanujan's formula could explain the behavior of black holes. His letter had described several new functions that behaved differently from the known theta functions or modular forms, and yet closely mimicked them. And for people who work in this area of math, the problem had in fact been open for 90 years. Thanks very much for watching. Namaskar.